let us look at dielectric material as one of the factors that affecting the capacitance of the capacitor and the parallel plate capacitor. Or in the parallel plate capacitors, we have what we call what? Dielectric what? Material. So if you are talking of dielectric material, is an insulating material, is an what? Insulating what? Material which prevents the flowing of what? Of electric charge or current in a what? A conducting material. So insulating material that prevents what? The flowing of charge or current between two metallic conductors is called dielectric what? Material. And this dielectric material may be air, may be plastic, may be silica oxide, may be paper. Any insulating materials are called electric what? Material. So dielectric material dielectric what? Material. This can be divided. This can be what? This can be divided as an insulating material. Insulating what? Material or insulating material which prevents the flowing of charge. Flowing of what? Electric charge or current from metallic conductor. From what? Metallic conductors. And the electric material can be what? And it can be polarized. And it can be polarized when applied electric field is passes through it. An example of dielectric material, examples are, we have air, the dielectric material, we have paper, dielectric material, we have plastic, the dielectric material, we have rubber, we have silica oxide. So all these are electric material. But let me show you the structure of the dielectric material. I've done that before. Assume we have a conductive plate like this and another conductive plate like this. This is a what? A plate. Let me put here. This is the plate. Yes, and this is what? The second plate. If this plate contains what? If the plate we have here contain positive charge, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. Yes, we can see that what? These are the conductive plates that is a outward charge. But from electric field, the positive charge is a source of electric field. That is a must for this what? Positive charge to produce electric what? Electric field. This will also produce electric field. This is also produce electric field. Also produce what? Electric field. This also produces own electric field. So this field is coming out from the what? From the source of what? Of charge. And we can now call what? The field is what? There is E. So this charge, this field will move from what? Positive charge to the what? To the negative charge. But in order to prevent the movement of the field from the positive charge to the negative charge, or to prevent the movement of the what? Of the charge from what? Negative to the positive, we are now need to what? To fill this space with what? With dielectric what? Material. This black dot we have here is represent what? Di what? Electric what? Electric material. The black dot we have at the center here represent di what? Dielectric what? Material. So this black dot that I used to fill this space is what we call dielectric what? Electric material. Good. So once this dielectric material is here, it will now prevent the what? The electric field to move from positive what? To move from positive plate to the negative what? To the negative plate. So it's an insulating material which prevents the flowing of the what? Of electric field or electric charge or electric current from one plate to another. That's what we call dielectric material. And when this field is being what? Electric field is being applied to the what? To dielectric material, the electric material will be what? Will be polarized. What is polarized what? This will be from what? Positive charge and what? Negative what? Negative charge. So the negative charge will move toward the what? The positive charge. Every charge will move toward the what? To the negative charge. And so what? When applied field is passed through the what? To the electric material, it will be what? Is being polarized. And the tendency of what? Of the electric material to what? To prevent the flowing of field or charge, we call it what? Dielectric what? Strength. So the next one is what? Let us look at the strength in which the dielectric material is used or is applied to prevent the what? The flowing of the what? Of the charge and electric field in it. So the next thing now is what? Is dielectric strength. Dielectric what? Strength. What is the dielectric strength? Dielectric strength is the maximum electric field. This is the maximum electric field. Electric what? Field that a material can withstand. Can what? Withstand without breaking down or conducting electricity. So dielectric strength is the maximum electric field a material can what? Can withstand without what? Breaking down. That is, the strength, maximum electric field that this material can withstand before it can what can break down. When the field is more stronger than what the electric material, the diagonal what will break. So when it's that break, the field will now what move from positive charge to negative charge. Then the electron will also move from negative plate to the positive plate. So the maximum electric field that a material can withstand without breaking down is called what? Dielectric strength. But mathematically, I can also divide dielectric strength in this form or another way. Di what? This can be divided. This is defined as the maximum potential difference PD V per unit distance D between the plates of a capacitor. Look at this definition. The maximum potential difference, the PD, across the what? The potential difference across the what? Across this place, which is V, and this distance between the what? The plate, which is what? D. So, can I say what? It is measured in in PD per what? Volt per meter. So mathematically, I'm having what? The dielectric what? Strength. You call it what? Dielectric strength equal to what? The maximum what? Maximum PD, which is V, over what? Distance apart, which is what? D. You can now say what? The electric strength equal to the word V over what? Over D. And it's measured in what? Volts per what? Per meter. That is what? The electric strength, the electric material. The last one is what? Dielectric constant. Let's look at dielectric constant. Dielectric constant. The symbol is what? Is K. So dielectric constant is the ratio. So what? This is what? Is the Y as the ratio of capacitance of a capacitor ratio of capacitance when filled with a material open bracket C to capacitance when filled with free space. With space is C what? Not. So mathematically, we are going to have what? Mathematically, we are going to have K should be equal to what? The ratio of what? Of C over what? C naught. When placed in what? In medium over what? Free space. We can say what? Where what? K is the electric constant. C is what? Capacitance. Is the capacitance of a capacitor. Is the capacitor of a capacitor when filled with material, with dielectric material. And the second C is when filled with air or free space. Air or free what? Space. Where K is what? Is dimensionless. So this is the what? Dielectric what? Constant. Dielectric material is an insulating material that prevents the flowing of charge or current between two plates. And the maximum electric field that electric material can what? Can absorb before it's breaking down is called dielectric strength. Dielectric constant is the ratio of capacitance of a capacitor when it's filled with what? With material to the when is in what? In a free space. So next thing is what? Let's solve one question on this. So before we what? Okay. Let's solve one question on this before we move to the next aspect. Yeah, question one. So what? Okay. Let me say the capacitor or capacitance of a capacitor 20 microcoulomb 20 microwatt coulomb. Hmm. When filled with yes, when filled with when filled with free space. When filled with this free space, okay, then what will be what will be its capacitor or capacitance? Capacitance when filled with the electric material or when filled with what? Medium mm, filled with medium, filled with medium Which dielectric constant is 2.5? Good. So if you are given this kind of question, how are you going to solve it? Solution. Don't forget, we have what? Capacitor of filled with what? Free space is CO, which is 20 microcoulomb. Good. What will be the what? C without in the medium. The electric constant K is given as 2.5. We can now say using K equal to what? C over what? C naught. We are looking for the what? C of medium, K C naught. What will be the final answer? K is what? 2.5 multiplied by 20 multiplied by 10 raised to the power 6 microcoulomb. 2.5 times what? So it's 50 microcoulomb. That is what? Answer. So we are done for what we call dielectric material. The only aspect of dielectric material which I skip is the polarization of dielectric what? Material, and I believe the scope of it is above the 100 level physics, JUPEP, IGMB, and what? And JAM. So let us move to the what? The arrangement of capacitors.